Hi, this is part 5 in the landscape series on the Houdini YouTube channel. And today we're going to be looking at how do we extend the size of the playable area of the terrain. So right now we're looking at a terrain that's 5 by 5 kilometers. So we're going to double that. And we're also going to be looking at how do we create the illusion of an endless horizon. How do we make it so that we have sort of terrain data all the way up to the horizon? So we're going to answer both of those questions and produce an image that looks a lot more whole. We won't be having any more sort of floating terrain tiles. It'll just be one integrated terrain that looks like it's part of the Earth or part of a world. So how are we going to go about doing that? Well, we're going to go back to the first data source that we used, and we're going to get the 3 adjacent Lidar terrain tiles that we can stitch together with this one here. And if you're not familiar with how we did that, then I'm going to suggest you go back to the start of this playlist and watch the first video and probably work your way back up through the videos to get back to this point here. If you want to learn how to make your own terrain material like we've done here, then you'll also need to follow parts 3 and possibly 4. Or I should say definitely 4 and possibly 3 if you're a beginner. So, okay. I'm going to go quickly back to the website that we downloaded the LiDAR data from. So it's the Defra survey data download. This gives us the LiDAR data for England, and you can also find via another website, another online portal, the LiDAR data for Scotland and for Wales, and they're both freely available. It's not completely exhaustive. You will find that certain patches of the UK are missing. This is possibly because they haven't finished scanning it yet, or because it's around an area which contains sensitive information like military installations. You can also get the LiDAR data freely available for Norway, and I'm sure many parts of Europe also have their data freely available, the data. And not only that, you can find the US has vast portions of the United States LiDAR data freely available. I've already downloaded the 4 other tiles, or I should say 3 other tiles, which are adjacent to the LiDAR terrain tile that we've set up here. So I'm going to jump back into Houdini, and you can see the result of the first and second workshop here. We have the input height field there, and the Heightfield project, which we projected to make sure that it was the right resolution. And then down here, we also have the LiDAR sort of extraction of masks and textures, which we use to drive the weights. We did that in part 2. So for the time being, we're just going to pull this Heightfield file up out of the way, kind of have a clean workspace. We're going to leave it connected for the time being. And I'm going to duplicate this Heightfield file 3 times to bring in the 3 other LiDAR terrain tiles. But before I do that, I'm just going to go down to the very bottom right of the scene where you can see it says on mouse up. And I'm going to change that to manual. And the reason I've done that is because when I copy this file, I don't want Houdini to freeze up on me. Whenever you do a kind of heavy operation like reading large data into Houdini or an operation with lots of nodes linked together, it's possibly going to hitch up Houdini, and there's no reason to do that for each of these individual files. What I'm going to do before I do that is I'm just going to plug in all of the separate DTMs that I've downloaded. There we go. I'm going to copy that path there. And I'm going to plug each of those in there. And once I've done all of that, I think that's the SW I want. Let's have a quick little look. That's the SE, that's the SW. There we go, they're all different. So then once I've done that, I'm going to quickly go ahead and create a merge node. So I'm going to press Tab and type in merge, like that. And then I'm going to hook these nodes into that merge node there. Now, I'm going to set my preview to the merge. And I'm going to change this back to on mouse up, which means whenever we change a parameter, it's going to cause this cook operation to begin down here. So it's just reading in those files, and now they're all on top of each other. Obviously, we don't want that. So what I'm going to do is first of all, we're just going to separate them. We're going to spread them apart, and then we're going to assemble them like pieces of a jigsaw puzzle. So I'm going to pull down this parameter view here, and I'm going to scroll down, and I'm going to offset it. So I'm going to change the center. I'm going to put this one to 5,000 in this direction. I'm going to do the next one. I'm going to put this one on minus 5,000. And finally, I'm going to put this one to 5,000 in the z-axis there. And now if we have a look from the top down, we can see that none of these terrain slices are correctly positioned. So we're actually just going to have to mess around a little bit until we find the correct arrangement. So I can see this central piece. I don't really want to move this central piece. I'm going to leave it where it is. So that's going to be over here. And I basically just need to look at the other terrain files and find where I think they will fit into the first one. So I'm going to hazard a guess, looking at this, that this chunk off to the right is actually on the opposite side of this chunk here. So which piece is that? I'm just going to change the focus to one of these chunks at a time to find the piece I want to move. I think it's this one here. Okay, that's the one. So I'm going to select that one. And I'm just going to change the center to -5,000 now. And we can see that that's hooked up correctly there. So that's contiguous. I'm now going to grab the piece which is overlapping that one, which I believe is, I'm not sure, quickly have a quick look. Heightfield file 3 here. And I'm going to leave that on -5,000 there, but I'm going to try pushing it to -5,000 here too. Let's have a look if that's worked. Okay, so that's correct as well, which by process of elimination means that we need to move this last piece just by -5,000 in this axis here. So we're flipping it to the other side, and we've assembled one contiguous piece of terrain, or we've nearly assembled one contiguous piece of terrain. If I go down here and click the I or more information button on the merge, you can see we've actually got height mask 4 times, and that means that they're all separate terrain data. It's not one terrain for the time being, and we want to merge this data all together to have one large terrain. So what I'm going to do at this stage is I'm just going to right click and type in HF, or press tab and type in HF to get just a plain empty height field. And we're going to scale that to match the proportions of this height field over here. So we know that this height field is 10,000 by 10,000 meters, and this one currently is just 1,000. So I'm going to add a 0 to each of those. And I think at the moment that's a little bit offset. So what I can do to make sure that's all lining up correctly is I can mouse over the merge and I can press this little pink preview icon down below. And there you go, indeed. You can see that the orange grid, it's very faintly overlaid on the world grid, is currently not lining up correctly with that height field that we've just created. So I think I just need to nudge that small amount in the X and Z axes. Okay, so that's the wrong direction. I'm going to go the other way. I'm going to go the other way down here too. Hi guys, I'm George. I'm the creator of the Houdini YouTube channel. I just wanted to take this moment to give you a small nudge and say, if you like this kind of content, if you're finding these videos useful, please like the video and subscribe to my channel, as it's hugely motivating and just makes me want to keep on producing more content like this. I've got a ton of stuff planned in the coming videos, not just terrain content. I want to do an entire course based around how do we create foliage inside of Houdini, how do we knock SpeedTree off of its throne. I also want to talk about splines. How do we use and abuse them, make them do our bidding inside of Unreal and Houdini? And just generally, how do we fuse these two amazing pieces of software to produce awesome results that neither alone is able to accomplish? So if this sounds like the kind of thing you'd be interested in and you want to see more of it, please let me know. Show your support, as that's just going to motivate me to carry on producing this kind of content. All right, thanks for that little, for paying attention during that little aside, and I'll let you get back on with the tutorial. Okay, and I'm just going to save the project there, and we're just going to take a moment to pause before I jump in and sort of blend that data into the terrain there to say that, yeah, this is a 10 by 10 kilometer terrain, and you might be wondering why we don't just keep them separate and import them to Unreal using world composition. And you'd be absolutely, fair. It'd be a fair question to ask. And if you are pretty experienced with terrains, I can't be the person to tell you not to do that. However, in my experience, world composition is often way, way, way more trouble than it's worth, even for really large worlds. And the reason for that is because working with one large terrain is orders of magnitude simpler than having to work with little slices of a large open world terrain. And it's going to make your life a lot easier, a lot more hassle-free, and that'll increase the amount of iterations you can do and therefore increase the result that you can hope to achieve. So, okay, enough of that. What we're going to do is, after this Heightfield node down here, we're going to create an Heightfield project. And we're just going to plug this Heightfield 2 node into the green pin of the Heightfield project. And we're going to take the output of this merge one and plug it into the white pin there. And now we're going to just change the preview over to the Heightfield project and see what we get sort of out of the box. Okay, so we've got a result, and you can see it's already worked. We've just projected all of that data into the Heightfield 2 terrain here. And if we press the little I button again to get some information, we can see that the resolution of this terrain is 5,000 by 5,000. So that's only a quarter of the resolution that we're getting from these Heightfield files over here, but that's not really a problem. If you overlook, like if we zoom in really close to the terrain and have a little look and then sort of flick between these two, you're going to see we do lose a little bit of information. But this kind of comes back to the point that it's a lot easier to and a lot faster to iterate with slightly lower resolution terrain data. And, you can always add props on top. You can always dress on top. So it's worth sacrificing a bit of resolution in the interests of ease of use, ease of working with data, because that increases the amount of iterations you can do. And you can really see that when we look at the distant terrain, which is where how the terrain looks becomes really important, you can see there's almost no difference, maybe a slight difference in sharpness, which you can always get back through the texturing anyway. So it's going to be barely noticeable. So we're happy to lose a little bit of resolution. But remember, Unreal only accepts certain landscape terrain sizes. And the terrain size that we're going to go with, again, is going to be 4033. So what I need to do is I need to select this Heightfield 2 node over here. I need to go and change the division mode to by axis. Now, it's going to think for a second, and I don't really want it to think. So what I can do to just break out of this operation is I can just whack escape on the keyboard. And you can see that that's cancelled out of everything. Really useful. Sometimes you have to press escape more than once in Houdini to get it to truly cancel an operation. But if you ever accidentally kick off a chain of nodes that you're like, oh no, I can't be bothered to wait for that to finish right now, you can just press escape to cancel out of it, usually. So I'm going to go and change the focus over to this height field now. And okay, we can see now we've got grid samples 512. So what does that mean? Well, it means if we press I here, we can see the resolution of the landscape is only 512 by 512. That's not what we want. So this is set to 4033, and now I'm going to rerun that Heightfield project operation by changing the focus to the project. Okay, so we've got that data now reprojected to the size that Unreal likes to receive it in. But you'll notice that we've got this horrible slice down the middle of the terrain. And we've got the same thing happening on this other axis. So, or axis, again, I need to really look up how to pronounce this word. So how do we deal with that? Well, it's quite simple, really. We just sacrifice a tiny, tiny amount of accuracy in the terrain data, and I really mean tiny, in order to close that gap there. We just go up and grab each of these Heightfield file inputs, and we change the size to 5001 meters. So they have each of them has a 1 meter of overlap. And once you've increased that padding by a meter, you'll notice we can fly under the landscape, and we no longer see those weird sort of stretchy bits there. So there's no real change to the landscape. We're probably losing under, I don't know, less like a fraction of a meter's precision compared to the real world data. And in exchange for that, we get this nice fully integrated terrain. Okay, so we've created a much larger playable area. It's 10 by 10 square kilometers, and it's the same resolution as the initial data that we exported and put into Unreal. So what we're going to do now is we're just going to put down a little node called file cache here, and we're going to save the results of this to disk. So every time we open the Houdini project, it's going to have to load these files, it's going to have to apply this project, and it's going to have to do every operation that creates the output result, unless we use this little node called file cache here. So I'm going to select the file cache, and I'm going to change it to save current frame, like so. And then I'm going to hit save to disk. It's going to save out the result of these nodes, and then I'm going to hit load from disk. And now if we change the focus of the file cache, it's going to look no different. And it just means that next time we open Houdini, it's not going to have to rerun this logic up here. So the only thing I'll say in addition to that is you just got to be a little bit cautious, because if you would make any changes to the input files up here, you have to remember to come down to the file cache and hit save to disk. Okay, that's the only caveat there. So we've got this new sort of combined terrain. We've combined the 4 tiles of Lidar data, and you could really combine as many tiles as you wanted in order to make a terrain as big or as small as you need. At this stage, we don't really need to change an awful lot else. We could get rid of this Heightfield file 1 and this Heightfield project here, since we've already got a projected and correct resolution file. So we'll go ahead and we'll delete those nodes. Oh, that wasn't the right way to do it, apparently. So, okay, what I'm going to do is I'm actually going to delete this Heightfield. Now, this is a weird peculiarity of Houdini. So I want these nodes to just go plug straight into this file cache. And if I was to delete this project here, you're going to notice that they will go straight up to the Heightfield 1 over there. So what I need to do is I just need to make sure that this is the first input. So this is, again, me just being a little bit lazier. These nodes below are always going to automatically hook in to the first input of the node above it if you delete that node. So I'm just going to select this node and press Shift-R to switch those over, and then I'm going to delete it. And that's going to make these wires all connect to the file cache there instead. Okay, so we've got that generated. We've got that saved, and now I can actually just have a little look. If we go down to the mask by feature here, just takes a little moment, and it's running that operation where it picks out all of those lovely terrain details. So I can go through each of these one by one and write these outputs to disk to overwrite the previous outputs. So I'm going to select this Heightfield output here, which outputs the terrain height, and I'm going to hit save to disk. I'm going to grab the next one. Actually, we've got another file cache here. So if you remember what I said, this file cache is still going to be using the old information. So if I load it up like this, you can see that's using the previous terrain data. Whereas if we go up to this flow field, it took a while to run, but that's a completely different result to what we're getting from the file cache. So what we need to do is we just need to select the file cache and hit save to disk. It's kind of a redundant file cache here, actually. So I'm just going to delete that file cache since we're always going to be saving to disk with the layer anyway. I'm going to hit save to disk on the layer 1 there. And there's nothing preventing you from grabbing more than one of these outputs at a time and saving them both together. Now I'm going to select one of these and I'm going to click this floating file chooser there. I'm going to expand that path so I get the path to the file on disk. I'm going to close it again, go to Windows Explorer. I'm going to paste that there. And you can see we've now got our new files export onto disk there. And we've got the old one called Lidar height. I'm just going to delete that. So these are all of our new height maps. Okay, so at this point, before we build the background terrain that's going to stretch off into the distance, that's going to be part 2 of this tutorial. We're just going to go into Unreal and we're going to import the new high resolution terrain. And we could just go press Shift 2 to go into the landscape editing panel. We could just right click on the Heightfield here in the layers and import from file and select the new terrain, pasting in that path I copied earlier. We could just select that here. But then we're going to have to change the scale factor. We're going to have to double the scale factor. And I don't really like doing that because it actually will make the center of the, it'll make the center, you can see right now, the origin of the world. I don't know if you can see right now, actually. Let's zoom out. There we go. You can see that the center of the landscape is in the center of the world, which is good because it means that the area that you're playing in is going to be sort of close to the world origin, which reduces something that we call floating point errors the further away you get from the world origin. But you can see that the actual pivot of the landscape is bizarrely on this corner here. So if I was to import the terrain and overwrite it and then scale it, we would actually end up with a terrain that filled this region. And that would be meaning that the far corner of this playable terrain over here would be a lot further away from the world origin than it needs to be. What I really want is I want the terrain to be imported to this region of the world. So the simplest way for me to do that, by the way, I'm pressing Alt-J to jump to top-down view like that. You can press Alt-2 to switch to wireframe, and then Alt-3 is base color for lit, etc. And then I'm pressing Alt-G to jump back to the perspective view. You can also press Alt-H to go to a side view, and Alt-K to go to the front and back view. So I'm going to go back, I'm going to press Alt-G back to perspective, and I'm just going to delete the terrain. Dun-dun-dun. Okay, so I'm going to press Shift-2 now, and I'm in the landscape panel, I'm going to hit Import from File, and we're going to specify that new terrain height that we exported. Remember, you can see the use of copying that path there because it means while I'm working with the same files, I can just always paste that into whatever sort of file chooser or folder chooser for whatever program I'm using. It's just really neat little, I mean, it's the simplest thing, but it's something that once I started doing it, it really sped up just these kinds of annoying tasks, importing things. So I'm going to double click that terrain height there. And you're going to see it's already, just like the first time, detected the correct resolution of the terrain. But what has it not detected? It has not detected the size of the terrain. It hasn't applied a scale factor. So right now, it's just going to be 4,000 by 4,000 meters or 4 by 4 kilometers. And the terrain we know is 10 by 10 kilometers. So how do we calculate the correct extents for the terrain? Well, that's quite easy. We just open up the calculator like we did in the first lesson. And we write 10,000 divided by 4,033. That gives us the scale factor. You can see that the scale is 100 by default. So we need to multiply that by 100. And that's going to give us the scale factor that we need to apply to the terrain to make it actually fill 10 by 10 kilometers. And actually, there's something else I forgot. So right now, we're assuming that the vertical height is the same height as the first terrain, but that might not be the case because we're using more terrain tiles and perhaps the highest and lowest points of the landscape have changed. So I need to go back into Houdini and have a look at this Remap node here. And we're going to change the focus. You can see that when we click on it, it appears to be just completely flat. And it is basically flat. It's actually just between a height of 0 and 1 meters now. But the reason we've used this remap isn't to actually scale the terrain. It's just to give us the actual input min and max height of the terrain, so the real altitude. So you can see that that first tile we had a min altitude of 71 meters and a max of 851 meters. Now let's compute the range again and see if that changes. I'm not expecting it to change too much, but in the sake of being accurate, let's give it a shot. Yes, so barely any change at all. So I'm putting back to 0 and 1. I will just re-export that to disk, just so that we have the most accurate data that we can. Jumping back into Unreal, I don't actually even need to change the import Heightfield file, I don't think, but let's do it again anyway. So I'm going to copy that. I'm going to copy the scale factor for the X and Y just to make sure I don't lose it. I'm going to hit reset file, and now I'm going to go and select it again. There we go. And okay, it remembered the scale anyway there, so that's good. And now we just need to input the Z-axis scale as well. So if we go to Houdini and have a look in the remap, we need to make a note of these two values. And we need to, first of all, find what is the distance, the actual sort of difference between those two values. So I'm going to do 851.275 minus 71.6895. And that gives us the true elevation change across the height field. We're going to copy that. And if we were to refer back to the landscape technical guide, we would find out that the true height of the terrain range is 512 in Unreal. So if you have black in the height map is going to be 0 and white is going to be 512 meters. So we need to find the conversion ratio between 512 meters and the value that we just computed in the calculator. I copied that, so I'm just going to now paste that, which is 779. So to get that, we just do 779 point whatever divided by 512. That gives us the scale factor. We times that by 100 because Unreal's landscape scales are multiplied by 100. And we can copy that, go back to Unreal, and we paste that in there. And we see a slight change in the elevation. And at this stage, we can also apply the material. So we're going to search inside of here, inside of our project. Where did we save that? We've got the MI GT landscape that we created last time. I'm going to plug that into the material there. And we can see that's populated this little layers drop down now. So if we expand that, we also have the opportunity to assign the weight maps that we created previously, or the weight layer info, and the weight maps. If we go into here, we can see we can assign those. So I'm going to find the grass is just going to be filled everywhere. So we'll actually leave that. We'll actually leave that for the time being. So I'm going to not fill those weight layers. We'll do that in a second so we can do them in the correct order. I'm going to hit import. So there we have our terrain. It's not looking correct at the moment, and that's because we haven't imported those weight maps. We're only getting the slope blended information. So we need to, inside of the landscape mode, go to the paint panel, and you can see we've got those layers again. And the reason that we didn't import those layers at the start is because when you're using weight blended layers in Unreal, the order in which you import them matters, because each subsequent layer will overwrite the previous layers that you've already imported. If you're using non-weight blended layers, that's not the case, but non-weight blended layers have some peculiarities of their own, and we'll be discussing how useful they are in a future video, but also how to sort of avoid some of the problems when working with them. Okay, so to begin with, I just want to fill the terrain with grass. So I right-clicked and I clicked fill layer, so you can see we've got grass everywhere now. And now I'm going to go and I'm going to import that rock layer, which I believe to be this map here, terrain layer 3. This is the map which picks out the ridges. And finally, we're going to go and import the sediment as well, which I believe to be terrain layer 1. Okay, so we're back where we were, but this time with a 10 by 10 kilometer landscape. So it's quite a lot bigger. But it's not big enough. It doesn't extend to the horizon. If you were a player walking around on the terrain, we're all the way down here, you might be okay in this sort of region, but what if we go up to the top of a mountain? Well, if we're at the top of the mountain, we're going to very quickly see that the terrain just ends. Now, common solutions to this are to build in vista meshes, which are specifically placed around the borders of the terrain just to hide those kind of open spots. But the problem with this is that they're not truly connected to this terrain, and when we're working from real-world data, we do actually have the opportunity to do something a little bit more clever and a little bit more exciting. And we can actually get the real-world height map data and extend it up as far as the eye can see. So how are we going to do that? You might think that we'd go back into the Lidar data download page and download the tiles, but that would take a really, really long time, because when you're at eye level down here and the terrain's completely flat, you can actually see terrain up to about 100 kilometers away. And if you're up at the top of the mountain like this, you can see the terrain up to about 200 kilometers away. Since these tiles are just 5 by 5 kilometers, that's going to take, well, let's figure it out. Let's figure it out. 200 kilometers divided by 5. That's going to take 40 tiles in every direction. And that's going to be 40 square tiles in every direction. So that's going to take just a huge amount of time to download. You're going to end up with enormous amounts of data. It's just going to take forever to process. So we don't need data to be that high resolution for our background terrain anyway. So we're just going to start from lower resolution data. Now, this is where we're going to go back to Houdini, which has another great tool to help us out. All right, so if you made it to the end of the video, congrats. I mean, it was only a short video, but if you've made it this far through the series, thanks for sticking with it for so long. Next time, we're going to be looking at how do we make the horizon effectively endless. So when you're in the playable area, you can look anywhere. You can stand on top of the tallest mountain and look in any direction, and you'll be seeing beautiful, high-quality terrain as far as the eye can see. We're not going to be using little vista meshes for that. No, we're going to be using real-world data again, just like we did here for the Lidar, except we'll be using a lower res data source. To give you a sort of a sneak preview, if you want to start getting on with that before the next video releases, the node we're going to be looking at is Mapbox. It's a native node inside of Houdini if you've got the Labs extension. If you don't know what that is, then just wait, and I'll be talking about that in the next session. In future sessions, we'll also be looking at how do you, we're going to go back to the materials. We're going to make the materials look a lot more banging. And we're also going to be looking at how do we start distributing props, foliage, forests, paths, tracks, all those kinds of things on the terrain. So really, we're looking with this series, I'm looking to make an end-to-end, how do you go from like never having made a landscape before inside of Unreal with Houdini to making something that, you know, you could effectively put into a AAA game, and or at least, you know, you'll be getting close to that level. Obviously, those AAA games have entire teams working on them to make their environments really sing. But for one-person operation, we're going to do the best we can. And yeah, thanks again for watching. If you like this kind of content, please like and subscribe. It's hugely motivating, and I'll see you next time.